All right, let's take a look at 10-3, which is all about chords in a circle. Number 14 starts this out. What is Ashton's error? So Ashton is trying to find the length of TS, and he did PR squared minus PS squared, which was 12 squared minus, he said 9 squared. However, he needs to use two other values to find TS. He needs to use PT squared minus PS squared, hypotenuse minus the other leg. So he needs to do TS equals the square root of PT squared minus PS squared, which is the square root of 9 squared minus 6 squared, which is the square root of 81 minus 36, square root of 45. So TS equals 6.7 instead of 7.9. He needs to use different values there. 18 and 19, 20 and 21 are all about this diagram to the left here. So we see some information at the top as well. It says find the measure of angle PBR. And since we know that arc PR is 90, the central angle is also the same as the arc, so that is 90 degrees. The measure of arc TV, well, we know that the measure of angle VBT is 90, so the exterior arc is also 90 degrees. Which angle is congruent to angle QBR? So QBR is this one right here. And I know that QR is equal to TU. So since the arcs are congruent, the angle UBT is also congruent. So angle UBT. And then which segment is congruent to TV? So here's TV. The segment that is congruent to that one is going to have the same central angle. So this angle right here. So that'll be PR. Number 23, find CD. So in order to find CD, I'll just say, well, I know that CD is equal to double of AB. And since they're both the same distance from the center, I know that CD is the same length as AB. So 15 times 2 is 30. So CD equals 30. And I think one got down here for some reason. So 24, find FG. So same thing. I see that the chords are the same distance away from the center. And EH is 21, so EG is 42. So FG is also 42. Number 25, a chord is 12 centimeters long and 30 centimeters from the center of the circle. Let's draw that. All right, so we've got a chord, 12 centimeters long. Here's the center of the circle. It's 30 centimeters from the center. And of course, we measure at a right angle. What is the radius of the circle? So the whole chord is 12. So I'm going to write 6 and 6 for each half of the chord. And I'm going to put the radius of the circle right there, so I can use the Pythagorean theorem. So 30 squared plus 6 squared equals x squared. It's going to give me 936 equals x squared. Take the square root of both, and 30.6 equals x. So the radius of the circle is 30.6. Number 26, again, draw a circle here so that we can explain. So the diameter of a circle is 39 inches. So if that's the diameter, it goes right through the center. And I can also think of that 39 as being cut in half to be 19.5 and 19.5 as far as the radius. 19.5. The circle has two chords of length 8 inches. What is the distance from each chord to the center of the circle? Guess we really only need to draw one in there. So there's a chord with a length of 8 inches, and I'm finding the distance from the chord to the center. So if it's got a length of 8 inches, then half that chord has a length of 4 inches. So I can use the Pythagorean theorem, again, to find that missing length. I know 19.5 is the hypotenuse, because that's the radius of the circle. So 4 squared plus x squared equals 19.5 squared. So 16 plus x squared equals 380.25 minus 16. X squared equals 364.25. And of course, we'll take the square root of both sides, and x equals 19.08. 27. Nadia designs a water ride and wants to use a half cylindrical pipe. Oops, I'm missing one. I'm sorry. Let's not skip 27. 27. A chord is 4 units from the center of the circle. Let's see. You got to draw the center of the circle. There's the chord, 4 units away. The radius of the circle is 5 units, so the 5 can go right here. What is the length of the chord? Oh, so I just need to find the length of the missing side here. And I happen to know that the numbers 3, 4, and 5 are a right triangle. I can call those a Pythagorean triple, which we haven't really talked about yet, but we could, which means that if this hypotenuse is 5 and one of the legs is 4, then x is 3. If half the chord is 3, then the entire chord is 6 units because I'm doubling it. Now for the water slide. Nadia designs a water ride and wants to use a half cylindrical pipe in the construction. If she wants the waterway to be 8 feet wide when the water is 2 feet deep, what is the diameter of the pipe? All right. So the water is 2 feet deep, and let's draw in what would be the center of the circle if that was a full circle, because then we can make some triangles. We can go all the way down to the bottom with one of our lines, just kind of straight down to the bottom there, and make a right angle on this chord. And we can split the chord exactly in half that way. So we have a 4 and a 4. We know the depth of the water is 2 feet, so I can put that where I've drawn a line in the water. We want to find the diameter of the pipe, which means we want to find the radius of the pipe first. I'm going to go ahead and write the radius in this spot, or going the other direction. So I have a right triangle here. It's got a side length of 4. It's got a radius of x. And then I also need to remember that this piece that I've drawn from the center to the bottom of the water is also a radius. So part of that radius is 2, which means the rest of the radius can be expressed as radius x minus 2. All right, that's really hard to read there. Let me see if I can get a better color there. So this radius is going to be x minus 2. So that means I have all 3 sides of a right triangle, and I can use the, I can use the Pythagorean theorem to come up with the answer. So I'll take the 2 sides of my right triangle, 4 squared plus x minus 2 squared equals hypotenuse x squared, and solve. So 16 plus, I've got to FOIL x minus 2, right? So that's x squared minus 2x minus 2x, so that's minus 4x, plus negative 2 times negative 2, so plus 4, equals x squared. Then I can solve. I'll subtract x squared from each side. Got 16 minus 4, 16 minus 4 can be put together, right? So that's 16 plus 4, 20, minus 4x. I swear I can do math. Equals 0, because I've subtracted x squared from that side. So let's go ahead and add 4x to that side. We can put something there. So 20 equals 4x. Divide both sides by 4. 5 equals x. But remember, 5 represents the hypotenuse of this triangle, which represents the radius of the whole circular pipe. We want the diameter of the pipe. So we're going to take that radius of 5 and multiply it by 2. Say the diameter is equal to 10 units. All right, let's do the next one. Number 30. I like number 30. So number 30, let's see, where are we at? A bike trail has holes up to 20 inches wide and 5 inches deep. If the diameter of the wheels of Anna's bike is 26 inches, can she ride her bike without the wheels hitting the bottom of the holes? And explain. Let's see. So what we want to figure out is whether the distance from the center to the edge, so we know the radius, which is 26 inches, is going to be longer or shorter than the actual height of the hole. Okay? So let's think about how to do this. We can make a triangle because we can draw a chord into this circle, bike tire right here, that is a 20-inch chord. And I can use half of that. If I draw this line straight down, I can say, well, half of that is 10. Let me erase the 20 here. Try this again. There's my chord, 20 inches long. It's 10 and 10 when I divide it in half and make a right triangle. I also know that the radius of this circle is 13 because the diameter is 26. So 13 is the radius. And I need to figure out what is the amount that my bike tire goes into the hole. That's basically what I'm looking for. I'm looking for this X right here. So let me redraw this in a place where you can see it. So I've got this right triangle. I know that half the chord is 10 because that's half the width of the hole. And I know that the radius is 13. So I just need to find the depth that the bike is sticking out of the hole to figure out if the rest of the bike is more or less than 5 inches in the hole. So I've got 10 squared plus x squared equals 13 squared. So 100 plus x squared equals 169. Solve that. X squared equals 69. Take the square root of both sides, and x equals 8.3 roughly. So then what I can do is I can say, okay, out of the 13 inches on this bike tire, 8.3 of them are completely above the hole. So 13 minus 8.3 gives me 4.7, which tells me that the bike tire is 4.7 inches into the hole. But the hole is 5 inches deep. So that bike tire is not actually reaching the bottom of the hole. It's right above it when both of the edges of the tire are at the edges of the hole. So I can say tire is 4.7 meters, not meters, inches. 4.7 inches deep in the 5-inch hole. So she won't hit the bottom. She won't hit the bottom. There we go. Number 31, we have a hemispherical cake, which is always weird. The bottom of a hemispherical cake has a diameter of 8 inches. That's nice that they give that to us, because if that's the bottom of a hemisphere, we know the radius of the cake is 4 inches from the center to any point. If the cake is sliced horizontally in half so that each piece has the same height, would the top half fit on a plate with a diameter of 6 inches? So we're slicing the cake horizontally in half. Well, what's the height of the cake? I know it's a hemisphere. So I know that this would be going from the center out to an edge of the cake. And that means that the height of the cake is the same as the radius of a cake, or 4 inches, half of 8 inches. She's cutting exactly halfway across. It's not a very good exactly halfway, but you can pretend with me. So there are 2 of those 4 inches above the cut and 2 of the 4 inches below the cut. I'm trying to figure out if this top half has a diameter that is more or less than 6 inches. So I need to find the diameter. I need to find a way to make a right triangle. Well, one thing that I can do to make a right triangle is use another radius of the circle. If I put a line right there, I can create a convenient radius, which also acts as the hypotenuse of our right triangle. And of course, that radius is 4. So that radius is 4, which means that I can make the Pythagorean theorem. X squared I don't know, plus 2 squared equals the radius of 4 squared. So x squared plus 4 equals 16. Subtract 4. X squared equals 12. And take the square root of both sides. X equals 3.46. So that's the radius of the top piece. Since that's a chord, we have to double it to figure out the diameter of that top slice. So 3.46 times 2 equals 6.92. Will it fit on a plate with a diameter of 6 inches? Since it has its own diameter, that top piece of cake has a diameter of 6.92, it will not fit. Will not fit on a 6-inch diameter plate. A 6-inch plate. It's too big. There we go. Couple more here. We've got 32. So 32 says which must be true. Select all that apply. So it looks like QR, arc QR here, and TU, those happen to have congruency marks on them. So we know they're congruent. For B, PR and TV are the same distance away from the center, so we know that they're congruent. C, VW equals AS, so VW is half the chord here. AS is the distance to the chord. There's no relationship between those, so we don't know C. And then D, PS equals SR, we know that chord gets cut in half by the distance away from the center, so we know that that is true. And finally, here's kind of a crazy one. The radius of the semicircle is R. So the entire radius is R. And CD is 3/4 the length of AB. What is the distance from the chord to the diameter? So we're looking for this distance right here. So let's think about how we might be able to do that with a well-placed radius. If the radius is here, we can call that radius R in the right triangle that we create. And it also says that CD is 3/4 the length of the radius. So that means that, let's see, if CD is 3/4 the length of the radius, that means that the diameter, CD is also 3/4, I can't talk. It's not half the length, it's 3/4 the length of the diameter. So CD is 3/4 of the length of the diameter, which also means that D to the center is 3/4 the length of the radius. So from the center to D is 0.75 times the radius. The same way, the entire CD is 0.75 times the diameter AD. I can use those two pieces and then an X for the distance from the chord to the diameter and use a Pythagorean theorem. So 0.75 R squared plus X squared equals the entire radius R squared. 0.75 R squared is going to be, let's see, I have it as a fraction, 9/16. Okay, why not? So I have 9/16 R squared plus X squared equals R squared. We'll subtract 9/16 R squared from each side. Oh, because I need it in a fraction. Minus 9/16 R squared. That's going to give me X squared equals 7/16 R squared. This is just algebra at this point. And I don't want X squared. I want the square root of X squared, which means I want the square root of 7/16 R squared. So doing this in multiple pieces, the square root of 7/16 is going to be the square root of 7, which is not simplifiable, over the square root of 16, which is 4, and then the square root of r squared, which is just r. So my distance is the root of 7 over 4 times r, or b, as my answer. So that's a really weird one. I don't know if I would expect you to do anything like that. But anyway, that is everything I've got for you for 10-3. Let me know if you have any questions, and have a great day.